So on Wednesday, a few of you were gone for ACT testing and stuff, but we'll get that recording posted for you here today so you can go back and review that as you need to. Today we are looking at the next step in our calculations, and that is reverse calculations. On Wednesday, we spent our time calculating IV flow rates and all the different forms of IV flow rates. Today, we want to go the opposite direction. And as we mentioned at the end of class on Wednesday, one of the most common practices there is to calculate the time required to infuse. So if we have a given volume, if we have a bag hanging in the IV stand, and we know how much fluid is in that bag, and we know what the flow rate is, and we know all the other characteristics, we want to look at how long it's going to take to infuse that bag of medication. Reasons for this, one is you don't want an empty bag hanging there. If it's done, you want to get it unhooked so that the patient can be more comfortable and so that it's not, it lessens the chance of bacteria and other infiltration into the system. The second is oftentimes the doctor's order is going to be for more medication than what is contained in a bag. So you're going to have to hang a bag, infuse it into the patient, and then when it's empty, you're going to have to switch it. So you need to know how long it's going to take before you have to switch out that bag with a fresh one to keep administering the medication to the patient so that they don't become deficient on their medication levels. So the first example we're going to look at is we're going to look at doctor's order. Actually, we won't look at the order. Sorry, the bag says that it contains 2,400 milligrams of our medication. And we look at the label on that bag, and it says that it is constituted at 40 milligrams in 15 milliliters, and that it has a drop factor of 19 drops per milliliter. And then we look at the infuser itself, and the setting on the infuser shows it is set at 45 drops per minute. And we want to know how long this is going to take. So we're looking for, we'll start out the easy way with it, an answer in minutes, and then convert that into other units as necessary once we get to that answer. Now, there are several ways to approach this problem. I'm actually going to do this particular problem 3 times here. I'm approaching it from a slightly different angle, starting from a different spot each time. Doing a pure dimensional analysis approach to this, we would look at the units that we want. We want minutes. And then we'd look at the units that we have. And we want to find one of the given pieces of information that has minutes in the unit. And the only one we see that has that is right here, the setting. Now recall that we've mentioned each of these rates is action equivalency. 45 drops per minute is saying that 45 drops is equivalent to 1 minute of elapsed time. So 45 drops per minute is also 1 minute per 45 drops. And since we want minutes to be our unit on top, I'm going to write it like that, 1 minute per 45 drops. This puts drops on top, which is where we want it to be, because we want that, or sorry, not drops. It puts minutes on top, which is where we want it to be, because we want our final unit to be in minutes. And now it's just a matter of doing conversions to actually eliminate that bottom number. We get rid of any units in the bottom. Well, right now that is drops. The only other thing that we have here that has drops in it is the 19 drops per milliliter. So I'm going to put drops on top so that they cancel out. That'll be 19 drops per 1 milliliter. So the drops will cancel out. Right now we have minutes per milliliter We want the minutes, but we don't want milliliters. We want to get rid of those completely. So we keep searching here, and we see that we look for something that has milliliters, so we can get rid of milliliters. And we see this here, 25 milligrams and 15 milliliters. Now the milliliters have to go on top. 15 milliliters, 40 milligrams. And the milliliters will cancel out. Well, now we have minutes per milligram. Again, we want the minutes, but we don't want any unit on bottom, so we're going to keep going. And what we end up with here is the doctor's order has to come in there at some point. Remember, we had said we wrote that before as 240 milligrams over 1. That's how we started our other calculations. We're going to put it in here in that same way. Now the milligrams cancel out, and we are left with no units on bottom, which is what we want. So now it's a matter of going through and multiplying this all out. On top, we have 1 minute times 19 times 15 times 2400. You have 684,000 minutes on top. On bottom, we have 45 times 1 times 40, which of course is just going to give us 1800. And it's now all we have to do is divide that out to get how many minutes that equates to being. So 684,000 divided by 1800 gives us 380 minutes. Now, that was what we said we wanted, was 380 minutes. To be practical, we would probably convert that into hours and minutes. To do that, it's easiest for me at least to use a fractional approach. 380 minutes is equivalent to 380 60ths of an hour. So it's saying we take, 60 minutes in an hour, we just divide by 60. And to turn that then into a more recognizable number, we'll make it into a mixed number from that improper fraction. Now notice I am leaving this as 60. I could have reduced this to 38 over 6, actually even 19 over 3, but I didn't want to. I wanted to leave it as 60 because when I'm done, the remainder, if I leave it in this form, the remainder is going to be meaningful to us. So 60 goes into 380 6 times. 6 times 60 is 360. We subtract, there's 20 left over. So as I was mentioning, this is meaningful to us. The 6 here is whole hours. The remainder down here is the minutes left over. So that is saying that this takes 6 hours and 20 minutes. So 380 minutes or 6 hours and 20 minutes is the time required to infuse. Now I had mentioned we were going to do this a few different ways. Here, I started with that flow rate, the drops per minute, or I actually changed it to minutes per drop, because it had the time on top already. But realistically, we could have started with any piece of information in here, and we could have got to where we needed to go. For example, we could start with the concentration, the 40 milligrams in 15 milliliters. If I started with that, well, I'm going to need to get rid of both of them at some point. Let's put milligrams on bottom to get rid of milligrams. Well, the only other thing I have that has milligrams is the doctor's order. That's the 2,400 milligrams over 1. Here it's going to be 1 over the 2,400 milligrams, so that the milligrams cancel out. So I've got rid of the milligrams. I just have milliliters. I need to get rid of that in favor of minutes. I'm going to put milliliters on top. The only information I have here with milliliters in it, other than the concentration, which I've already used, is the drop factor. That is saying 19 drops per milliliter. I'm going to put 19 drops on bottom and 1 milliliter on top, so that the milliliters will cancel. And now I need to get rid of drops. The only thing left with drops in it is my actual flow rate, which is the 45 drops per minute. Now the drops cancel out, and the only unit I have left is minutes, which is what I want my answer in. However, here the minutes are going to be in an undesirable place, and I'll show you how to do that once we get this calculated out. So on top, 40 times 1 times 1 times 45 is 1,800. On bottom, 15 times 2,400 times 19 times 1 minute is 684,000 minutes again. Now you'll notice here, we have the exact same numbers as what we did up here, only upside down. It's reciprocal. Remember, we said that what we're dealing with here is rates. What this is saying is that 1,800, whatever, there's no units there, is equivalent to 684,000 minutes. So I could either have the 1,800 over the 684,000 minutes, or we could do the reciprocal. We can flip it over, have the 684,000 minutes over the 1,800. And we would want to do that because it wouldn't make sense to divide it the other way and have it per minute. That's not a time unit. That's a rate. So dividing this out, once again, would give us 380 minutes. So that's something that I wanted to do in this early on today, in this second example, is show you that when you get to the end, if you have the correct unit, but it's on the denominator, in the denominator on the bottom of the fraction instead of the top, we can do that. We just pull the numbers apart and put them back together as flipped over as a reciprocal. If the units are right, just reciprocated, we can take the reciprocal to get the correct units. So I started with the actual flow or the concentration there just to show you that possibility. But in reality, there's no common sense reason why you would have started with the concentration. Either we would have started with the flow rate like I did in the first example, or because we're so used to always starting with the doctor's orders, we would have started with the doctor's orders, which was the 2,400 milligrams. And as always, we would have put that over 1. And of course, we need to get rid of milligrams, so we'll put milligrams on bottom. The only thing we have with milligrams is that concentration again, 40 milligrams in 15 milliliters. So the milligrams cancel out. Well, we still have to get rid of milliliters, so I'll put milliliters in there. The only other thing we have with milliliters in it is our drop factor. 1 milliliter is equivalent to 19 drops. So the milliliters are gone. And next we need to get rid of those drops. Well, the only thing we have left with drops in it is that actual flow rate setting of 45 drops per 1 minute. And so now the drops have canceled out. The only units we have left are minutes, and it's actually on top again. So we do the calculation on top. It's actually the same numbers in different order. 2,400 times 15 times 19 times 1 minute is 684 minutes, or 684,000 minutes. Over 1 times 40 times 1 times 45 is 1,800. And once again, it divides out to be 380 minutes. So I did that problem 3 ways. I'm not going to do that with every problem because I'm not going to try to confuse you like that. But I want to do it that way so that you can see that with dimensional analysis, it doesn't really matter which one of the units we start with, which one of the given pieces of information we start with. As long as we keep working with the units, we're either going to get to something that has the units we want or the reciprocal of the units we want. And we can get our answer from that either way. So with that said, let's do another example here. The example I'm going to throw out here is we have a bag that says it contains 2,400 milligrams of medication again. And the label on that bag says it contains 12 milligrams in 5 milliliters. And the drop factor is 8 drops per milliliter. So a much smaller drop factor. So more viscous fluid, higher surface cohesion, larger drops. And then, of course, we look at the flow rate. That setting for the flow rate is, what is that, 32 drops per minute. And again, we're going to calculate the time to infuse. So we want our answer in minutes or hours in minutes, depending on how big that number is. So for simplicity here, let's just start with the bag. The size of the bag kind of replaces the doctor's orders in this situation. So 2,400 milligrams over 1. We want to get rid of the milligrams. We'll put it on bottom. The only other thing we have with milligrams is 12 milligrams in 5 milliliters. So put the milligrams on bottom so they cancel out, and the 5 milliliters on top. So the milligrams cancel. We now have milliliters as our only units. We want to get rid of those as well. The only thing we have with milliliters in up here is the drop factor. So I'm going to put milliliters on bottom so they'll cancel. 1 milliliter is equal to 8 drops here. So the milliliters cancel out. I have 8 drops as my drop factor. Want to get rid of the drops. Well, the final piece of information we have here does have drops in it. That is the 32 drops per minute. So 32 drops on bottom, 1 minute on top, and the drops will cancel out. So on top here, we have 2,400 times 5 times 8 times 1 minute, which is going to give us, I believe, 96,000. There it is, 96,000 minutes. On bottom, 1 times 12 times 1 times 32. Well, 12 times 32 should be 384. There it is. So we just divide that out. 96,000 divided by 384. We get 250 minutes. So we can either leave our answer as 250 minutes, or we can change it by dividing it out. 250 divided by 60. Oops, 60. 60 goes into 254 times. 4 times 60 is 240, so there's 10 left over. So that is saying 4 hours and 10 minutes is the time to infuse. So that bag would need to be changed in 4 hours and 10 minutes. Well, I'd said I wanted to get you guys trying a few more problems. So I'm going to let you guys try a time to infuse problem here. So for this problem, the bag is going to contain 1,500 milligrams of medication. The label on that bag is going to tell us it's constituted at 25 milligrams in 8 milliliters with a drop factor of 12 drops per milliliter. And our setting on the infuser, the flow rate, it is set at 24 drops per minute. So fine for me, you don't have to convert it into hours and minutes, but simply find the minutes it's going to take to confuse. I'll give you about 2 minutes here and then we'll go over that. Let's take a look and see how you did on this. So we will start out with the amount in the bag. So the 1,500 milligrams, put that over 1. We need to get rid of milligrams. We'll put milligrams on bottom. The only thing we have of milligrams is our concentration. 25 milligrams and 8 milliliters. So the milligrams cancel out. We now have milliliters. Oh, we want to get rid of milliliters. Put those on bottom so they cancel out. Brings us to the drop factor. 1 milliliters is equivalent to 12 drops. Or if it's easier for you to think of it that way, 12 drops is equivalent to 1 milliliter. So the milliliters cancel out. We're now in drops. Get rid of that. We'll put drops on bottom. The only number we have left is the 24 drops, which is equivalent to 1 minute, which is our flow rate. The drops cancel out, and now all we have left is minutes. So we'll have 1,500 times 8 times 12, which I believe is 18,000. Oops, sorry. Missed that one by ways. 144,000 minutes. Over on bottom, we have 1 times 25 times 1 times 24, which is 600. So we'll divide that out. Divided by 600, we get 240 minutes. Those 240 minutes, or if you divided that out, that actually comes out to be exactly 4 hours. Either of those would be an acceptable answer there. So the next step is, what if we're looking at switching out a machine? So the infuser starts to malfunction and we have to switch over to a different infuser. We need to know the settings. And if the first infuser shorts out, we can pull the information out of the chart. But let's say we look in the chart and what we find is the doctor's order was 2,000 milligrams over 8 hours. And we see that the label on the bag is showing that it's 25 milligrams in 12 milliliters. And we can see that the old setting was 30 drops per minute as the flow rate, but we don't know the drop factor. So in order to set up the new infuser, we're going to need that drop factor, and it's going to be in drops per milliliter. So now here again, we could start with anything. Let's go ahead and start with the doctor's order since that's what we're so used to starting with. Didn't need to cross that out. There we go. So we have 2,000 milligrams over 8 hours. Well, we need to get rid of both of those things. I don't have anything, and usually I go for time first. I don't have anything that has hours in it, but I do have minutes over here. So let's get rid of the hours by saying 1 hour is 60 minutes. That'll cancel out the hours. Now we're in minutes, and we can get rid of minutes because we have our flow rate here. We'll put minutes on top, 30 drops on bottom per that 1 minute. Now the minutes cancel out. Now we have drops here. We do want drops in our answer. Now drops are on bottom here. We're going to want them on top, which is fine. We'll have to just do a reciprocal later. We still need to get rid of the milligrams on top there. I see up here, I still have my 25 milligrams in 12 milliliters as my concentration. So the milligrams are gone. I now have milliliters. So the 2 units that I have here are milliliters and drops, and those are the 2 units I want. But we see that they're inverted. It's a reciprocal. So let's multiply the numbers out, but before we divide them, we're going to go ahead and flip them over to get the units in the correct spots. So on top here, 2,000 times 1 times 1 times 12 is 24,000 milliliters. On bottom, 8 times 60 times 30 times 25 gives us 360,000 drops. And as I said, since we have milliliters over drops right now, and we want drops over milliliters, let's go ahead and take that reciprocal. So 360,000 drops over 2,400 milliliters. And now we'll divide it out. 360,000 divided by, not 2,400, but 24,000 gives us 15 drops per milliliter. So there's our drop factor, 15 drops per milliliter. So that was using the old standby, starting with the doctor's order or the total amount in milligrams and working from that. If we didn't want to go through this process of doing a reciprocal at the end, we could do some analysis before we start to see that we want drops in the numerator of our answer. We have a number that has drops in it, so we can start out with that drops in the numerator and go from there. So 30 drops per minute is our flow rate. If we start with that, we'll start out with 30 drops over 1 minute, so we'll have drops in the numerator already. We need to keep the drops. We want drops to stay in our numerator. So we're not going to touch drops, but we do need to get rid of the minutes. However, the only other thing we have up here with time in it is hours. So we have to go the other direction with that. We're going to change the minutes into hours. So minutes will go on top. That's 60 minutes in 1 hour. And the minutes are gone. So we needed the hour there so that we could use the doctor's order of 2,000 milligrams over 8 hours. So I'm going to put 8 hours on top and 2,000 milligrams on bottom. We know that 2,000 milligrams is equivalent to 8 hours of flow, no matter which order we put them, top or bottom. The hours cancel out. Milligrams are on bottom. Well, we want that to be milliliters, so we need to keep going with that. Put milligrams on top, and we see that we had that concentration, 25 milligrams in 12 milliliters. And now the milligrams cancel out. We now have drops on top and milliliters on bottom. And we'll multiply. 30 times 60 times 8 times 25 is 360,000 drops. On bottom, 1 times 1 times 2,000 times 12 milliliters is the 24,000 milliliters. And we see that once again, that'll divide out. Dividing by the 24,000 will give us 15 drops over 1 milliliter, or 15 drops per milliliter. So as I said, I'm not going to keep doing the problems in multiple methods like this, but we could start either with the doctor's order where we're used to starting. In this case, we end up with something where the units are flipped over from what we want. So we just have to flip them back over before we divide it out. Or we can look at the units before we start and make sure we have a unit on top in the numerator already that relates to, that works with our desired unit in our answer. So once again, I'm going to give you guys a problem there to start. I'm going to have you try this in your notes. So the doctor's order is 3,500 milligrams over 5 hours. The label on the bag is telling us that it is constituted at 25 milligrams in 12 milliliters. And we have our setting as a flow rate of 30 drops per minute. So I want you to find for me that drop factor, drops per milliliter. Once again, I'll give you a minute and a half or so, and then we'll go over that. So we'll start out with the doctor's order, or we could start out with the setting, either one. I'm going to go ahead and start out with the doctor's order just because that's what we're used to starting with. So 3,500 milligrams over 5 hours. We're going to get rid of the hours. 1 hour is 60 minutes. Again, we had to get rid of the hours because the only other time we have is in minutes. Now we get rid of the minutes. Minutes will go on top to cancel out. 1 minute is equivalent to 30 drops. Minutes cancel out. Now we have to get rid of the drops. Actually, sorry, we have to keep the drops. We have to get rid of the milligrams. We have 25 milligrams. Now, milligrams are on top here, so we need them on bottom. 25 milligrams in 12 milliliters. So the milligrams cancel out. Now we have milliliters and drops, which is what we want. We just don't have them in the right position. So let's go ahead and multiply these out. 3,500 times 1 times 1 times 12 milliliters is what? 42,000, I believe, milliliters. I'm going to double check that one. Yeah, 42,000. On bottom, then, we have 5 times 60 times 30 times 25. Giving us 225,000 drops. Now, before we divide that out, we're going to do the reciprocal. So I'll put the 225,000 drops on top and the 42,000 milliliters on bottom. Now, again, we're able to do that because we know this is saying 42,000 milliliters is equivalent to 225,000 drops. Doesn't matter which one's on top or bottom. So we'll go ahead and divide this out. 225,000 divided by 42,000 gives us 5.36 drops per milliliter. So that one may not have come out nice and neat, but it works. So then the next thing we want to look at is, what if we don't know the concentration of our fluid? There are things we're going to talk about, titrations, next week, where we can adjust a dosage without having to redo the whole calculation. But we need to know what the concentration was in order to do that titration, in order to know how to do the titration. So let's say we have a label, or sorry, not a label, but an order for 2,500 milligrams over 6 hours. We know that the medication has a drop factor. We can get that drop factor off the infuser of 40 drops per minute. And we can see that the setting on the infuser has a flow rate of 16 drops. Oops, I screwed up. My drop factor, sorry. Put my flow rate in for my drop factor. Our drop factor is 16 drops per milliliter. Our flow rate is 40 drops per minute. Need to slow down my reading a bit. And of course, what we're trying to find is we're going to try to find the concentration that tells us how many milligrams in how many milliliters that this is constituted to. So once again, we'll start out with a doctor's order. 2,500 milligrams over 6 hours. Now here we want milligrams. Our concentration of so many milligrams and so many milliliters, remember, really is a fraction or a rate with milligrams on top and milliliters on bottom. So we want milligrams on top. We just need to convert those hours into milliliters. Well, as we look through this problem, there is nothing else with hours in it. We do have minutes, so we have to convert our hours into minutes. So 1 hour is 60 minutes. The hours are gone. Now we need to get rid of the minutes. Putting minutes on top, we have 40 drops per minute. So 1 minute is equivalent to 40 drops. That's from our flow rate. The minutes cancel out. And then we need to finally get rid of drops. We use our drop factor, 16 drops per 1 milliliter. So the milligrams are still there, but we have got rid of the drops now. Come on. And we have milligrams on top, milliliters on bottom, which is what we want. So we'll go ahead and multiply this out. On top, we have 2,500 times 16, which gives us 40,000 milligrams. On bottom, we have 6 times 60 times 40 milliliters, which is 14,400 milliliters. Now, when we look at this, this is not the way we're used to seeing it. There are a couple ways we could do this. We could go ahead and divide it out and get a decimal. 40,000 divided by 14,400, giving us 2.7777. If you happen to recognize that 2.7 repeating is 2 7/9, that's great. We can use that. Otherwise, the way to go about it, and I'll show you how that helps out in a little bit. Otherwise, we could just go about it as reducing an improper fraction. This is 40,000. We'll keep the milligrams on top. 14,400 milliliters on bottom. Well, both of them end with 2 zeros, so we can divide by 100, giving us 400 milligrams over 144 milliliters. Both of those can be divided by 4. 400 divided by 4 is 100 milligrams. 144 divided by 4 is 36 milliliters. Well, both of those can still be divided by 4. 100 milligrams divided by 4 is 25 milligrams. 36 milliliters divided by 4 is 9 milliliters. So there's the unit we want right there. This is saying that our concentration was 25 milligrams in 9 milliliters. Well, how could we have got that from this fraction here? Oops, I need to cross it off again. From this fraction here, this mixed number. Well, we take that mixed number, 2 7/9, again, milligrams over milliliters, and we turn it into an improper fraction. 2 times 9 is 18, plus 7 is 25. That's 25 over 9. Milligrams per milliliters implies milligrams goes with the numerator and milliliters with the denominator. So we would get that same fraction. Okay, so the last thing we really want to do here, and we are down to about a minute left, is to find the volume infused. In other words, if we're looking at a bag hanging there, we know the settings, don't necessarily need to know the order. We want to look at, maybe the chart tells us how long that bag is supposed to hang. If we're going through and double checking safe dosages of medication, we need to be able to calculate just how many milligrams of medication are going to be infused in the patient during that time. Well, we're down to only half a minute left, so this will have to wait for Monday to go over that calculation. For now, you have homework, page 178, 1 through 21, the odds, and page 184, 1 through 11, the odds. With that, we are out of time, so you all have a great weekend, and hopefully we'll see you all on Monday.